This is Urvi Chavara and this is my assignment number 4, part 1. I'm going to run this real quick. Let's run it for 9960. I hope we get some value. Okay, 0 and 60. Let's do 78, 10. Great. Let's do 79, 1006. Nothing matches that value. Alright, and if we enter it, quits. So this is how my code works. So I get the values, I get the inputs, I change them to integers, I map them to integers, and then I create a list using random to random between numbers 0 and 100 for the length provided by the user. And I sort the list using the Python built-in sorted function, and then I do the binary search on that. So the way that binary search works is I get low index, high index, which means the low index will have the lowest value of the list, and high index will have the highest value since the numbers are sorted. And if the low, so I get the values and sum the values that we have, like current value, like the value at index 0 and index length minus 1. If it equals the sum, the target sum that the user needs, then it will return the value. And if not, if the current sum is less than the sum num, then I keep on incrementing the index. So we don't want the numbers with the lower index, we want the numbers with the higher index. So we increment the lower index and keep the higher index the same, which is length. And if the current sum is greater than the sum num, so we need to go down because we don't need a sum that's bigger than the target sum. And since we know it's bigger, we chop off that one value, and then we decrement the high by 1, and then keep the low as is, and it keeps on doing that until we find something that matches the target sum, which is this. So this is some like it's similar to the recursive function. This is the base case we have, and it's O log n, because it does not go through the list n squared times. So if we had a for loop, let's say, so if we had a for loop, we would go to the list once and then twice and then twice and then until n times, right? But for this one, we only go to the loop, we only go to the list once, because not once, right? We only go through the list n times, since we keep on looking at each number and we keep on chopping it off if we don't need it. But yes, that's how the binary search works. We like splitting the list into two parts. That's my approach. That's it. Thank you.